So moving on now, we're going to start to address how we would go about testing strength. And we're specifically going to have a look at a methodology called a Handgrip Dynamometer. Okay, so just went sort of slowly and specifically there with spelling, just so you could have it nice and clear. So this Handgrip Dynamometer test is thought to be a pretty good measure of muscular strength, and let's include the word muscular in there. Excuse me, sorry. And equipment, first of all, we need the dynamometer itself. We can see the equipment here in the image. We do need an assistant who's going to help with adjustments, who's going to make sure the test is fair. And we may use a stopwatch because we are going to talk about a 5-second hold in a few moments' time. So a couple of first things in terms of the protocol, in other words, how we do this. We need to make sure that we've got the correct grip. Okay, so the way we're going to experience this is that on this little device here, the palm of the hand should be on the lower bar and the fingers should be wrapped around the upper bar on the first knuckle. Now, if that's not right, we've got a little dial here which allows us to adjust the distance between these 2 points. But first of all, we want the correct grip. Without the correct grip, this is going to be a less valid test. We're going to say that in all of these examples, the methodology is going to start with hand by the side, with hand by side. Okay, so in other words, this performer is going to start with their hand down here, with the actual device kind of here. Okay, so it's going to be sort of round here. You get the idea that the grip of the dynamometer itself is going to be down here. And actually, it's an interesting point, this. Depending on what you read and where you read, some people argue that when the test is actually undertaken, the hand should remain in this position. Others argue that it should be moved into a 90-degree angle at the elbow. And others still argue that as you squeeze, your arm should be raised so that it is parallel to the floor and that the device is in this position. So I'm not totally sure which one to actually advise you on here. But certainly just have an awareness of these three different methodologies. But what is to come now is the same regardless. We need the performer to conduct what we would call a maximal isometric contraction. Maximal isometric contraction. And if we remind ourselves what the concept of isometric is, it means an equal length contraction. So that means that when they pull downwards on this bar, they're going to pull and hold it, even though the bar itself is not going to continue to move downwards. They keep the pressure on it in an isometric equal length contraction. And this is actually done for 5 seconds. So we need the hold to be for 5 seconds. Okay, now at 5 seconds, we then take the reading and we record what that reading is. It's important we record that. It's important that we actually record that and get that reading from there. I'll come back to the reading in a second. A couple of other things. Different people argue different things, but really, depending on what you read, some people argue you then have 15-second recovery before you can repeat again, but others argue it is 60-second recovery. So I'll allow you to decide that with your teacher, which version of this test you're going to use. And then what is absolutely true, though, is that we would actually ultimately repeat this test. We do repeat this test. And when we repeat, we actually then take the best score as the formal score. Now, of course, this is different to the flexibility test, sit and reach, where we take the average score. Here, we're going to take the best score. And the other thing is we're going to take the best score from the dominant arm, the dominant side. So a couple of things before we look at comparing this. I want to talk to you about the concept. Let me just get up here. I want to talk to you about the concept of validity. Does this test what it's claiming it measures, which is muscular strength? Well, broadly, we're going to say yes, but we can also criticize it and say, well, maybe it only tests arm strength, okay? Which is why there are dynamometers for other parts of the body, actually. So there is a bit of a criticism there. Reliability, assuming we get the protocol right, we're going to say yes, this is a pretty reliable test. It's going to produce pretty reliable, repeatable results. And practicality, yes, it's a pretty it's a pretty practical test because it's relatively little equipment. It only takes 5 seconds. It's pretty quick, and it's not a technique-based movement. It is a maximal test, so that is sometimes problematic, but it's maximal with regard to strength, which means it's a very temporary maximal effort. A couple of last things from me. Let's look at advantages and disadvantages. So advantages are that it's simple, that it's reliable, and we've got relatively little equipment. I mean, we need the dynamometer itself, but it's pretty basic. Talking about a few pounds. Most times at a school, for example, will be able to acquire one of those. On the negative side, we would make the argument here that we've got the impracticality of the assistant who needs to do the timing and record the score, make sure that things are set up properly. And perhaps the other one, and maybe the most significant one, is that it seems to be a measure of arm strength or forearm strength. So on that basis, it might be preferential or beneficial to athletes such as rock climbers, for example, or rugby forwards, even though because it's only measuring that arm strength. If we're measuring whole body strength, then other types of performers might do worse in this test because they don't use strength in that way through their performances. So we just want to address that possibility. And rather embarrassingly, I actually forgot to put on the. Let me see if I can do it from here. I actually forgot to put on the normative data table for you. So I'm going to do it right now while I just select it from here. Let me just make it a little bit bigger. Let's have a look at the normative data table. Well, over here, we actually had an example on our screen. We had that this athlete here had scored 39.4, and I believe the hand is a male hand, so we'll assume it's a male hand, and then we can make a normative data comparison over here. So in this case, the 39.4 is going to mean that they are in the area of fair. Okay, so they're going to come out with a result here which is fair. I suppose, how would we say fair? Like not bad, not terrible, but below average. Fair, not brilliant. So in other words, we need to take our raw result. Let's take our raw result, and we need to analyze it against population level data, and we do that with, remind ourselves, normative tables. Normative data tables. Normative data tables. All right, fantastic. That's all from me. Thanks very much.